Okay, here's a recap of where we're at in the unit. Okay, you have to know how to simplify expressions. So you got 5a to the third power, and then to the second power outside of the parentheses, and you have a parentheses 3a to the negative fourth power, and then a second power. So the operation is all multiplication. Okay, so make your 3 lines, and then you underline the expression if there's no line there. Now, your factors are a 5, an a 3. Now if there's a second factor of a, which there is, you put a plus sign. Now, let's figure out the exponents. 5 is to the first power, and I take 1 times 2, so that's 2. Now there are 2 factors of a. Okay, here's the first one. 3 times 2 is 6, and negative 4 times 2 is negative 8. So I'm adding a 6 power plus a negative 8 power, and that's a negative second power. Then 3 is to the first power, and 1 times 2 is 2. Now, which of these have to switch positions? Not the 5 to the second. That's in a good position because it's positive. With the negative power, the a switches positions to the bottom, and it becomes a positive second power. And then the 3 stays in its position, 3 to the second. Now, out of these, the ones I can evaluate are the 3 to the 5 to the second and the 3 to the second. So it's 5 times 5, that's 25. And then 3 times 3 is 9. So it's 25 times 9, and then a to the second. Now, do we have anything we can multiply? I think we do. 25 times 9 can be multiplied. Okay, that's 225. So that's the answer, 225 over a to the second power. Now my next problem, I have a parentheses. I have 4x to the negative third power, a fifth power, and a second power outside the parentheses. So I underline the expression. We have 4 times x times y. So 4 is to the first power, and I take 1 times 2, that's 2. X, negative 3 times 2 is negative 6, and then 5 times 2 is 10. So you're distributing the exponents. So that maintains its position. That switches positions to the bottom, and the 6 becomes positive. Now that stays in its position. If it has a positive exponent, it stays in its position. Now out of those powers, the only one that can be evaluated is the 4 to the second. So 4 times 4 is 16. So that's replaced with 16. The variables stay the same in their same place. And you can't multiply anything because you don't know y. You don't know what the y is. Okay, next problem. We have a division line. On top we have 4a, b to the 6th, c to the 3rd. And on bottom we have a to the 5th, and then c to the 3rd, b, c to the 3rd. So now the division line's there. So on top we have 4a, b, and c. Now in the denominator we have a, b, and c. So on top 4 is to the first, but it ain't in parentheses, so we don't distribute. We just put a first. Then a is to the first, you don't distribute first, and then b to the 6th, c to the 3rd. Now, a is to the 5th. No, nothing gets distributed. There's no parentheses. Okay, b to the 1st, and then c to the 3rd. Now, you see if you can cancel stuff from top to bottom. So I got a to the 1st, a to the 5th. I cancel the smaller one, and then subtract 1 from the 5, and it's a to the 4th. I do the same thing with the b. Okay, you subtract the smaller one, minus it. Okay, 6 minus 5 is 5. And then these just go bye-bye because they're the same. So none of these need to switch positions because they all have positive powers. So the 4 to the 1st times the b to the 5th is on top. Okay, b to the 5th. And then the a to the 4th is on bottom. So I can evaluate 4 to the 1st. Ain't hard to do. It's just 4. And then the b to the 5th and the a to the 4th just remain the same. Okay, nothing you can multiply. That's simplified. Okay, next page. End behaviors of polynomial graphs without graphing. classify the polynomial function by the degree, by the number of terms, and then the end behavior. So you have y equals 3x to the second minus 8x to the fourth plus 9. Well, the first problem we have is this needs to be written in standard order. The negative 8x to the fourth comes first. There's no x to the third, and then the 3x to the second, and then our constant, which is 9. Now we're in a good position. It has 1, 2, 3 terms. The degree is 4 because fourth power is the highest. Now, don't draw this graph, just look. It means if I graph this thing, it'd form like a roller coaster kind of deal. What would it be doing on this side? Because this is your positive infinity. Well, it depends on the leading coefficient. The leading coefficient is negative 8. Since that is negative, since the first term is negative, it will go downward this way, which is negative infinity. Now, the other side, this is the negative infinity side for x, okay? What's it doing on the other side? Well, that depends on your degree. The degree is 4. Is that now? It doesn't matter if it's positive or negative. It matters if it's even or odd. It's even, so the end behaviors have to match. Okay. So if we know that's negative infinity, to match it would be negative infinity. Okay. Next one, y equals x to the 7th power minus 2x to the 5th power minus 4x to the 3rd power minus 2x minus 1. Okay, now that's in good order. It's in the order it needs to be. So the terms, 1, 2, 3, 4, 5. 5 terms, and the degree is 7. Okay. Now, to know the positive infinity, this side, the right side, you look at your leading coefficient. Okay. The leading coefficient is 1. It's positive, so we will have positive infinity here. Now the degree. We already know the degree is 7. That's odd. So since it's an odd degree, they're not a match. They're the opposite. Okay, it's a mismatch. So the opposite of positive infinity is negative infinity. Okay, now we're going to come back to this page here and this page here. Now I want you to go to this page. Find the roots by factoring. You just set it equal to 0 and then just put equals 0 here. I said I want it factored so it will work. So there are 3 roots, 3 solutions. Now you ignore the 0 and you count the terms. That's 3 terms. So that's GCF followed by our table. And I'll have to do a dots check over here. So do we have x on the last term? Sure do. Is first term negative? Nope. And then 1, 5, and 36 is 1. Now it's 1x, so you're doing it. Okay? Place that here. Now go divide everything by the 1x. So that's 1x third divided by x to the first is x to the second. 5 divided by 1 is 5. X second divided by an x first. 2 minus 1 is 1. So it would be x minus 36. 1 minus 1 cancels. Okay. Now ditch that. I don't want to see it there anymore because the t-chart is done from here. So ABC. 1 times negative 36 is negative 36. So we know that's a positive multiplied by a negative, and it has to add to negative 5. 1 and 36, no. 2 and 18, nope. 36 divided by 3 is 12, nope. 4 and 9, cha-ching, and it's negative 5. Now, this is the, just make 4 parentheses, okay? Just do it. If we don't have to use the other 2, we don't have to. So plus 4 minus 9. Now this is a part a lot of you guys mess up, okay? A is 1x to the second. Well, we don't need the 1, that's good. But I do break my x to the second into x times x. So x plus 4, x minus 9, and we don't need those because those cannot be reduced. Now see if those are dots. I know the plus isn't. The minus, x is not a perfect square. If it does the second power, I'd do it, but It's not. Okay, now you set your zero product properties. So this x is to the first power, 1 and 1. So I'm going to get 3 answers. So 1x equals 0. Be just 0. You don't even need the 1 really. X plus 4 equals 0. So I get negative 4. And then x minus 9 could equal 0, which means I get 9. So 0, negative 4, 9 are your 3 roots. Okay, roots, cross that crap out and put 0. So there's 4 roots now. Count the terms, there's 3. So GCF, and then the table. Okay, do you have x on the last term? Nope. And we need to do a Dobbs check over here. Negative in front, nope. 1, 20, 64 is 1. Get that out there then. Okay, I don't need to do it. So I'm not putting anything yet. So 1 times 64 is 64 positive. And I have to add the factors to try to get to negative 20. So it's going to be a negative times a negative. Nope. Divided by 2 is 32. 3 is a decimal. Divided by 4 is 16. Bingo. Okay. Now your A is 1x to the 4th. Okay. If your leading coefficient's 1, you get rid of it. Okay. X. By the way, if it's a 6, you don't break that down. You go 6, 6. If it's 12, 12, 12. But you do have to break down your exponent. So x to the second, and you know you got minus 4 and minus 16. Those cannot be reduced. Okay, there's no coefficient there to reduce by. So we have x to the second minus 4, x to the second minus 16. No pluses, so I check it. Well, x second's a perfect square, that's x times x. 4 is a perfect square, that's 2 times 2. X times x, and 4 times 4. So both of them go down, okay? So x2, x2, x4, and x4. So the pluses drop down. I basically do this till I don't have any more difference of perfect squares. The minus x is not a perfect square. The minus x is not a perfect square. Drop it. Okay, so 1 answer is coming from each one. That's going to give me 4 at the end. So x plus 2 could equal 0. It's going to be negative 2. X plus 4 could equal 0. Gives me negative 4. X minus 2 could equal 0. It's going to be positive 2. X minus 4 could equal 0. That's 4. Okay, all different roots. Okay, next page. Doing the same thing. Get that fx crap out of there and put 0. So, you have x to the third, so that's 3 roots. I'll just put it here. Okay, we have 4 terms. You need to do grouping then. Little parentheses times big parentheses. Okay, so we have 1x to the power of 3 minus 6x to the power of 2. Negative 4x plus 24. Okay, now these are each GCFs out here. Got x squared. No negative, 1 and 6 is 1. Don't have x. We have the negative. 4 and 24 on a chart's 4. So I'm going to divide by 1x squared here. I'm going to divide by negative 4 here. So that's going to be 1x. 3 minus 2 is 1. Minus 6. Same thing here. Okay? So in each parentheses we have 1x minus 6. And over here we have 1x to the second minus 4. Now check those for dots. So 1x minus 6, 1x to the second minus 4. You don't need those 1's in front of the x. Now that's a minus, but x is not a perfect square, so that gets dropped. That's a minus. X to the second is a perfect square. 4 is 2 times 2. So one answer comes out of each one. Okay. So x minus 6 equals 0. X plus 2 equals 0. X minus 2 equals 0. So plus 6, I get 6. I get negative 2. And I get positive 2. Okay, so those are your roots. Okay, now I want to direct your attention to this page. I totally jacked this packet up order. Find the quotient and the remainder. Okay? Okay, you're just dividing. That's synthetic division. The dividend 2, 9, 11, 3. Now you set your divisor equal to 0. So 2x equals negative 3 divided by 2. And that's negative 3 over 2. Okay, so that's what I put out here. You're going to need a calculator. 2 times negative 3 over 2 is negative 3. And you get 6. 6 times negative 3 over 2 is negative 9. You get 2. 2 times negative 3 over 2 is going to be negative 3. Well, there is no remainder. The remainder is 0. So it goes from 2x to the third to 2x to the second plus 6x plus 2. Now you don't need to solve. It didn't say solve. There's your quotient. Okay, let's go to the last one. Apply the rational roots theorem to find the zeros of the graph. So rational roots theorem, you go 0, but you don't try to factor this yet. Okay, you have to go RRT, and then after that you're going to synthetically divide. Now it's got 3 roots, and I need to find one by the rational roots theorem. The other 2 I can find using quadratic equation properties. Okay, so rational roots theorem, you take a constant and your leading coefficient. So the constant is 2, the leading coefficient's 1. So factors of 2, easy, 1 and 2. Factors of 1, 1. So you divide 1 by 1, it's 1. 2 divided by 1 is 2. So that's a pretty short list of possibilities. Okay. So I'm going to use that theorem to plug it in. So 1 parentheses 1 to the third plus 5 parentheses 1 to the second minus 4 parentheses 1 minus 2. Okay, right away I got my 0, so I'm good. So now set the 1 out there, and you're 1, 5, negative 4, negative 2. So I drop the 1. 1 times 1 is 1. Then we add, that's 6. 6 times 1 is 6. 2. 2 times 1 is 2. Okay. So I got remainder 0. Get rid of that. So now, that is now goes from 1x to the third to 1x to the second plus 6x plus 2 equals 0. So now I go to my GCF-T. Negative, you don't have x, you don't have a negative. 1, 6, and 2 is 1. 1 times 2 is 2, positive 2. So it's got to add to positive 6, so the signs have to match as positive, but that's not even possible because 1 and 2 is the only factors of 2 that exist. Okay, so write QF, quadratic formula. So opposite of B, plus or minus the square root, B squared minus 4AC, B squared minus 4AC over 2A, over 2A. So the opposite of positive 6 is negative 6. And then A is 1, Now I go into my square root, and b is 6. Then a is 1, c is 2. So we have negative 6. 2 times 1 is 2. Now, plug that in. Second square root. Remember, if you get domain error, you just enter it without the square root. But I didn't get it. It's 5.29. So I take negative 6 plus 5.29 equals, divided by 2, negative 0.36. Then I take the negative 6 minus the 5.29, divided by 2, I get negative 5.65. Those are irrational answers, but they